Hello, everybody, for coming this talk. We are discussing in this talk about the process to migrate our pipelines using Azure DevOps to a new declarative model using GitOps, using tools like ArgoCD, Kubernetes, Harbor, etc. So at first, I want to introduce my first. My name is Alfonso. I work as expert SRE in Leader Hub Digital. Jorge, please, can you introduce yourself?
Okay, I'm Jorge Turrado. I work with Alfonso and other folks. I am principal SRE in the digital hub of Lidl. And let's go further and start with the session.
The first thing that I want to explain is what is a deployment. I know probably everybody knows what is a deployment, but deployment is the process to transferring file from a develop environment to production environment. It's making an application available to receive requests and for the use that people can use the application. So if I get back 20 years ago, when I started to work, I remember that I started in a small company, and we have several servers. We have, for example, one server for Linux application, another for Windows application. And when I had to, I need to introduce a new feature in our web pages. So I had to copy the file from my local machine to the server using this kind of commands. Probably FTP is the most common that we use. So this process for making deployment is good in a small company. I don't know, probably some small companies still using this model, but in a big company like Lidl, for example, is not the best way. So this model presented at least two problems. It's a manual process and no backups exist. So some years later, it appears a new concept that it was the code repositories. Code repositories solve at least 3-4 problems. The first ones is it enhances collaboration with teams, with people, because you can make a change with any conflict. The second one is that you have a history of every main that you has made into a repo. The first is the backups, because as you know, code repository is a central storage. And this finally, code repositories is the best way for documentation. I always say that the documentation is in the repo and is not in the Confluent pages. So in the next picture is the moment to introduce a new concept, that is the concept of pipelines. As you know, pipelines is a series of automatic stage for deploying application automatically. In this picture, this is the real scenario that we started a little 5 years ago. We have build pipelines and release pipelines. In fact, we have some products that are deployed using this model. Build pipeline, as you know, create code, build the code, test it, and create an artifact. And this artifact is taken by release pipeline, and the release pipeline put this run this artifact into different environments. So this is the model that we using in Lidl during the last year. So if we move to the next slide, we started using boxes from Azure DevOps. This is the first pipeline that we did 5 years ago. And this kind of boxes worked very fine for us, because it's very intuitive to create a pipeline. this is the first time for you that you have to create a pipeline in Azure using boxes is very good. So, but when the products and teams started to growing, this model is not the best model, because any change that you through the portal is not recorded, and this kind of pipeline are very rigid. So the first thing that we did, it was moving from this kind of pipelines to pipeline as code using YAML file. So if, as you can see in the next slide, we started to migrate to this model using YAML files, and YAML files solve at least two problems. The first one is that you can use code repositories, and YAML files support more features than the boxes from the UI. So in this moment, in this scenario, we started to migrate in parallel our pipelines to pipeline as code, and our infrastructure to infrastructure as code. In this moment, we haven't any model for our infrastructure. We are using ClickOff model. A new term is create resources manually through the portal in Azure, and as you know, is the worst thing that you can do. And we started in parallel to migrate our products and deploy our products using in the same pipelines and the related infrastructure in the same pipeline. So this kind of pipelines, as you know, we migrate from ClickOps model to infrastructure as code using Terraform, as I told in the previous slide. So, and we decided to deploy in the same times the product and its related infrastructure in the same pipeline, and it worked very fine for us for the last 2 years. But we started to experiment some new problems. The pipelines take a long time in order to complete. We had 4 or 5 different environments, and if, for example, imagine if you want to deploy a new setting, not code, only one setting, you have to wait a long time, 10 minutes, in order to arrive to production environment. So it's when the pilots weren't agile. So in the same moment, we have experimented problems about our infrastructure, because we started to grow in number of users, and we started to receive a lot of traffic, a lot of requests in our products, and Azure Web Apps services fell short for us and didn't fit our needs. So in this scenario, that we have a pipeline that take a long time in order to complete, and a technology like Azure Web Apps that didn't fit our necessities, we started to think in a new solution, for deploying our application. And the solution was Kubernetes. So in this moment, we are using in a big part of our products Kubernetes, tools like Kida, Prometheus, ArgoCD, Harbor, etc. So one thing that I want to say about Kubernetes is Kubernetes is solve a problem for us, but not always is the best way for deploying your application. I know Kubernetes is a high, and everybody wants a cluster Kubernetes for running their application, but in our case, solve a problem. But if you have, for example, a small product, probably you don't need Kubernetes. But in our case, it was the best solution for deploying our application. In this moment, we want to move from Azure DevOps to a declarative model using GitOps model and Kubernetes, but we didn't want to introduce a lot of new features, a lot new technology at the same time in our teams, because it's very crazy for our teams understand all the new technology at the same time. So the first thing that we did is keep the pipeline from Azure DevOps. And as you can see in this image, we started to deploy in our cluster in Kubernetes using the same approach that you saw in the previous slide. We have a build pipelines that create an image, and this image is saved into Azure Container Registry or in Hayward, doesn't matter. And after that, we have another pipeline that take this image and run this image into different clusters and different environments. So this is the first approach that we did for deploying our application in our clusters in Kubernetes. And some month later, we started to move in to GitOps model. That is the model that we want to work in Leader Hub Digital. So, Jorge.
Okay, let me start. I'm going to remove you. Thanks, Alfonso. Okay, why are we using GitOps? What is GitOps? Okay, we came from the pipelines approach, from the DevOps approach, as Alfonso has explained. But with Kubernetes, it doesn't fit quite well because it's imperative. For deploying something, if we want to deploy something into the cluster, we need to use an imperative action like triggering a pipeline, execute a command, and so on and so on. The point is that why don't use the most extended repository source that we have? Why not using Git as the source of truth? Because at the end of the day, we want to have a reliable and repeatable scenario where we can deploy a new environment super fast from scratch without any kind of city and complex action from development side or from operation side. So using Git brings us a lot of improvements, such as the disaster recovery, because Git is the most extended backup that we have. Every developer within the organization will have a more or less recent backup because they pull the Git story every day or every week. So it's quite better than just having an imperative way where we need to check which version is deployed, how has it worked, and so on and so on. Second, there are some workers in the street that has decided to destroy my presentation. Okay, let's continue. Go ahead. The point is that, okay, we want to use Git as a source of truth. We want to synchronize our Git repository with our Kubernetes clusters because it's fine, it's super easy, but how can we do? How can we do this? How can we achieve this goal? Okay, the first step could be doing by yourself, but it's not the best approach. Do it yourself is nice, but if you reinvent the wheel, it doesn't matter at all. So there is a tool for GitOps known as ArgoCD. There are other options in the CNCF landscape like Flags, but in our case, we decided to use ArgoCD because we have thousands of developers that are not really familiar, are not really happy using CLIs and those kind of toolings, and ArgoCD brings that an option to use a really fancy and colored UI, which is nice for user experience. But keeping that aside, how it works, basically ArgoCD has a controller that will synchronize some repositories with our Kubernetes cluster. And we as operators, we as users, just need to define how are the relationships. I want to synchronize this Git repository with this Kubernetes cluster within this namespace with this kind of variables. And it's fine because we can just use this approach. But how it looks, how it works, and why I say The developer experience is nice because it's a colored screen and they have buttons and it's a less cognitive load than other tools. This is the screen that you are seeing at this moment is how it can look. Basically, let me open a share demo. This is my own demo with the environment. You can see that it's a workload. I can check how it looks. I can set the difference. Okay, which is the difference? The image will change. These things are happening because the value in the GitHub repository, GitHub is the source that I have used in this case, but you can use whatever you want if it uses Git under the hood. In this case, I'm using GitHub and I can see a suggested change. So it's nice because I can see with just a quick look what is pending to apply. But it's not only this, it's not only the user experience, it's also the easy way to manage multiple clusters and multiple deployments, because I don't need to be aware about how many clusters I have, where are they deployed, how can handle them in any different. For me, as operator, it's just a web page that I can go in and check all the workloads that I have in a single view, which is nice because they can be deployed on different clusters, in different namespaces, for different environment. Doesn't matter at all. They are just ArgoCD applications that are handled by the ArgoCD controller. And for me, it's a relationship between some Git repositories and some live installations of those kind of archives or files that I have in my Git repository. And how it looks, is it super complex? No, it's quite easy. I just need to deploy the ArgoCD CRD, an ArgoCD custom resource for the application, where I can define, in this case, it's a super happy path, but I can define which is the destination, which cluster, which namespace, in which project I want to deploy this, because at the end of the day, I need some kind of multi-tenant, I need some kind of segregation of the accesses to not bring admin access or just reader access to everything within the ArgoCD installation, because I would like to have multi-tenant to split the access and segregate the access by the team. And having the project and the destination, I need to specify the source. Which is the source? Just a Git repository, just a URL that can be used to pull the current manifest. It can be secure, it doesn't need to be public, it doesn't need to be accessible without any kind of authentication. ArgoCD supports several types of authentication processes, but for the happy path, you can just take any kind of public GitHub repository. And at this point, I'm going super fast because I don't want to extend so far from the expected time. With this approach, we can just deploy the infrastructure within the cluster, but it's not enough if you want to have some kind of quality ensured by the process, because just syncing the projects, they are syncing the applications into the cluster doesn't mean that they are safe. This could be explained for hours, but just to give a quick summary to wake up your curiosity, there are different kinds of progressive controllers that extend Kubernetes capabilities from a single rollout that just replace one pod with the other one, changing the version or anything that has changed, and checking the startup prog. You have progressive controllers that can bring you extended capabilities for rollout, such as real load balancing, executing some kind of test during the process, doing a blue-green deployment, or executing a canary rollout, and those kind of capabilities that are nice and we had to use to improve our deployment way. Nothing interesting at this point. And the point is, Argo Rollouts has another screen that can be integrated in ArgoCD and bring us a quick view about how the process is going. going back to the demo that I had, in this case, this out of sync process, this change is handled by an Argo rollout. In this case, the rollout is quite easy. I'm not going to go really in depth about this, but just the canary, the rollout process, the canary process is a change of the load to a 5% of the load to the new version. It's quite easy. It doesn't execute any complex analysis, but in this case, I will start a new application that only will receive the 5% of the traffic, which is quite nice to test new applications on production without any kind of disruption. Not for testing them, but for roll out them in a safe way, because you can perform your sanity test. You could perform also any kind of test directly during the rollout. Once again, we could be there speaking about ArgoCD and Argo Rollout for hours, but I think that I have overpassed the time expected. So let me execute the demo. When I sync the process, when I apply the change into the cluster, the manifest has already changed. So the deployment process has finished, but now the rollout process will start. And in this case, if I check how it's going, the new version, the canary version, is deployed. It has one pod, but not all the traffic will be routed to the pod, to the new pod, because it can be broken. It can have a critical bug impacting to all the users. In this case, I have just set the 5% of the traffic and stopped the rollout until a manual operator acts in this case, but it can be fully automated. In this case, just for finishing the demo, I will promote the version, and now all the traffic is automatically routed to the new version. So just doing a super quick summary, we started with FTP, uploading the files directly to the server, and at this point, we have a full package and a full automated GitHub process that takes the changes from Git repository, which is the best backup system and the best point of truth that exists at this moment. Automatically, those changes are synced into the cluster thanks to ArgoCD, and to roll out those changes in a safe way, all the changes are executed in the cluster in a progressive way with Argo Rollouts. And I think that we are almost done. We have passed 2 minutes, almost 2 minutes from the expected time. So let's finish quite faster. Thanks for your time. Thanks for attending to this session. Do you want to say something, Alfonso?
No, thank you for attending this talk. It's an honor to speak for us. Thank you. And thank you, Jorge, for your explanation. Bye-bye.